Hello everyone. Today I am going to discuss what is Coulomb law and what is its vector form. Coulomb was basically a brilliant French scientist who measured the electrostatic forces of attraction or repulsion between 2-point charges by using a particular device known as torsion balance and deduced a law which is known as Coulomb's law. Now, what is Coulomb law? Before that, all of you know that basically two same charges, for example positive or negative repel each other, and two opposite charges, for example positive and negative attract each other. So basically Coulomb measured this force of attraction or repulsion between two charges, and Coulomb experimentally verified that what are basically the main factors on which the repulsive or attractive force between two charges depends. Now let's discuss that. According to Coulomb, the electrostatic force of repulsion or the electrostatic force of attraction between two charges is directly related to the magnitude of the 2-point charges. For example, if the magnitude of the 2-point charges decreases, then the force between two charges decreases, and if we take bigger and bigger charges, or if the magnitude of the two charges increases, then the force between two charges increases. It means that the electrostatic force of attraction or repulsion is directly proportional to the product of 2-point charges. Similarly, if you decrease the distance between two charges, then the electrostatic force of attraction or repulsion between two charges increases, and if you increase the distance between two charges, then the electrostatic force of attraction or repulsion between two charges decreases. So it means that the relation between the force and the electrostatic force of attraction or repulsion are I mean that basically the distance between two charges and the relation between the force and the distance between two charges is basically inverse, which I say already that when you decrease the distance between two charges, the force increases, and when you increase the distance between two charges, then the force decreases. So it means that the force and the distance between two charges is inversely related, which is, according to Coulomb, F is inversely related to the square of the distance between two charges. Now if we summarize that equation and we take as a single equation, then we must put here a Coulomb constant, which is here is a K. This constant is known as Coulomb constant, which value is a 9 cross 10 power 9 Newton meter square per Coulomb square, and this Coulomb constant is further equal to 1 by 4 pi epsilon naught, where pi is 3.14 or 22 by 7, and epsilon naught is basically the permittivity of free space or air. Now what is the permittivity? Permittivity is basically the medium between two charges, which in this case we take here as a air or free space, and permittivity is basically the property of material medium which shows us that how much it affects the electric field between two charges or the electrostatic force of attraction or repulsion between two charges. So basically this is the permittivity, and we can find this permittivity from the light equation, which is already theoretically verified by Maxwell and experimentally verified by the Hards. Now the main question is basically here is force involved, and we know that force is a vector quantity. Now when the two charges are positive, then the electrostatic force will be repulsive, or when the two charges are of opposite sign, then the electrostatic force must be attractive, but this attractive or repulsive force must be in a particular direction. So force is a vector quantity, therefore we must have to put here an arrow on force in Coulomb law. So Coulomb law in vector form becomes like this: F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square. Now what is F12? F12 is basically the force exerted on charge number 1 by the charge number 2. and F21 is basically the force exerted on charge number 2 by the charge number 1, and R12 is basically the unit distance between charge Q1 and charge Q2. Similarly, if we take the distance with respect to charge Q2, then this distance is basically, we take R21. So R21 or R12 is basically the distance between two charges. So this is the vector form for the charge number 1. The force on charge number 1 due to charge number 2 is equal to this, while R12, here this R12 denote the direction of this vector force, which is basically a unit vector R12, which is further equal to the R12 divided by magnitude of R12. A vector divided by its magnitude is known as a unit vector, which determines the direction of a particular vector quantity. Similarly, the force exerted on charge number 2 by charge number 1 is equal to 1 by 4 pi epsilon naught K1 Q2 divided by R21 square, which is basically equal to this, where R21 is basically the unit vector R21 divided by its magnitude. Now, it must be noted that F12 and F21 is always oppositely directed, because from Newton's third law we know that every action has a reaction, and action and reaction both are equal in magnitude and opposite in direction. And the another main point is that these forces are always oppositely directed, whether the force is attractive or whether the force is repulsive. For example, if the force is repulsive, then forces F1 and F2 are in opposite direction, and if the force is attractive, then you see here the forces are again in opposite direction. So we must include here the negative sign, but the main important other point is that the magnitude of these two forces are always equal, but only in opposite in direction. Now, the vector form of Coulomb law is very important because it tells us that whether the force between two charges is attractive or repulsive. Similarly, this law also gives us the principle of superposition, and if we take more than two charges, then in that case, in case of more than two charges, there is a resultant force that act on a one charge due to the all rest of the charges. Then in that case, so we treat at the same time only two charges and find the force between their two charges. For example, F12, then the charge, the force exerted by the interaction between charge number 3 and charge number 1 is, let's suppose, F13, and the interaction between charge number 4 and charge number 1 is basically F14. Then we must sum up all these forces, which gives us the resultant force on charge number 1, or the resultant interaction between charge number 1 and the rest of the charges. So the principle of superposition is the main consequence of the Coulomb's law. Now, what are the basic examples in daily life or in daily occurring phenomena related to the Coulomb's law? The force between electron revolving around the nucleus and between positive nucleus is basically the coulombic force. The electron revolving around the nucleus because of the coulombic force of attraction. So there is a coulombic force between electron and the nucleus. Similarly, there is a coulombic force in molecules between two atoms, or the structure of the solid liquids are basically held by the coulombic force. Now, this law is valid only for stationary and point charges. Point charge mean which have no substructure, and point charges we take such that the distance between two charges is far off greater than the size of the charges. So Coulomb law is only valid for point charges. So the reason of that we will discuss later, and for that, if you want to know more about nature and what are basically further detail of these laws and the upcoming next law, then for that you must have to subscribe my channel. I hope you learn some basic things about the Coulomb law. So inshallah, next time with another interesting video. Keep in touch. Thanks.